Hmm? Can you?
Yeah, it's visible.
Perfect. Now I'll give a brief recap of what we have discussed till now. We have discussed what are the various approaches that we have for getting the security of our Android application testing. We have Android bug bounty. We have Android pen testing. We discussed about both of them. We understood them from the perspective of an organization. What is bug hunting? What is bug bounty hunting? How does it take place? What are the various phases of bug hunting? Then we discussed about pen testing. What is pen testing? Why do we do pen testing? What are the various phases of pen testing? Advantages, disadvantages of pen testing. Then we compared both of them, that what are the advantages that we have of choosing bug hunting over pen testing, and then we discussed the advantages of pen testing over bug hunting, and we also saw some of the pointers on the basis of which you can decide as an organization which approach is better for you. Then we saw what are some of the most common security attacks that can happen. We just had a name of them, that's it. Then we also saw about the Android attack surface, that why is it being told that in Android majority of the security issues are client side. Around 60% of the security issues in Android are client-side vulnerabilities. Some of them are logical, some of them are server-side. We discussed about them as well. How do we define the attack surface? Then we have discussed about the lab setup. We installed Mobaxler in our VMware/VirtualBox. Then we set up Genymotion. We installed an Android emulator Genymotion. We set up our Android device. In Genymotion, we installed the ARM translator. We installed OpenApps G Suite. We integrated our Mobaxler with Genymotion with the help of ADB, that is Android Debug Bridge. In ADB also, we have seen a lot of commands. We saw ADB connect, we saw ADB forward, we saw ADB locket, we saw ADB pull, ADB push, and others as well. We saw practical demonstration and their utility for us as a pen tester, as a researcher. After that, once you know how do we use ADB, the next thing that we can do is we can understand about the APKs. So how do you do the source code analysis? How do you understand the source code compilation? All of these things will be becoming more understandable for you and easy for you if you understand about an APK. APK here is short for Android Application Package, and I'm sure that after today's discussion, you will also be able to understand of why do various government organizations, various private organizations, and also governments of various states and countries will be telling you to not to download APK files or Android apps from any of the third-party applications like there are a lot of web applications online. There are a lot of third party app stores as well. I would not want to mention any of them, but there are a lot of third party app stores as well that are similar to Play Store, but you simply go there, you search for the app name, and you will be able to download them. How easy it is for any of the attacker to download an app, to extract the source code from that app, that is decompile it, to add malwares or trojans into it, and then give it to you. By looking at the application, you will not be able to tell that it contains malware. In our upcoming discussions as well, I will show it to you practically that how on any of the app can you add a Trojan for yourself? How you can add that Trojan for your victim, for your target? We would not want to do that for any of the legal purpose, but we would want to do that for the sake of POC, for the sake of learning, that this is how things can happen and this is how easy it is. Just so that you can become more concerned, just so that you become more aware of why should you not be downloading anything from the unauthorized sources. So for me to be able to explain you those things, I need to first help in understanding about APK, that is Android Application Package. You must have seen it quite frequently that from any of the website or maybe from any of the file sharing app that we have, like Share It or Zoom It or Zender, we can quickly share the apps. So in those apps as well, the APK files are being shared. So APK is short for Android Application Package. APK is simply a zip. It is similar to a zip file, not exactly zip, but it is basically an archive. So I mentioned zip here because all of you know this extension zip. So APK is basically an archive of a lot of things as in you will be having png files. You must have seen that when you install any of the application, you get to see the logo, like when you use WhatsApp. Here as well you can see in this Android device, for all of these apps that you have, all of these logos that you see, like this for Citibank, for this, for the Firefox, for the Opera Mini, all of these various logos that you see, these will majorly be given to you in the form of maybe a png file or maybe in the form of a svg file. So this is a part of that archive. Similarly, you will be having the Java or the Kotlin code, that will also be a part of this archive. You will be having some of the XML files, that will also be a part of that archive. So there will be a lot of things that you will be having in any of the APK, and that is why we call it an archive. In one of our previous discussions, we had learned about the complete Android compilation process. When we were discussing about the Android OS architecture, I mentioned about this compilation process. I will give you a brief overview here. What we do is we will simply be having the Java code. That particular code that we will be having, with the help of Java compiler, we will be converting it to Java bytecode using Java compiler. We will be converting it to Java bytecode. Then this bytecode that we will be having, this bytecode will further get converted to DEX file with the help of DEX compiler. This will get converted to DEX file. DEX here is short for Delphic virtual machine. Just as the Java file that you have, it gets the extension .jar. Similarly, the DEX file that you have, the .dex file, that is short for
Could you go a
Delphic.
little more slow, sir?
Yes, Anas.
Could you go a little bit more slower? I'm
Let
missing
me
out a
take
little. I'm
down.
taking down notes, sir.
Sure, I'll do that.
Okay, sir.
So just as we have a Java file that has the .jar extension, with the help of Java compiler, it will get converted to Java bytecode. That Java bytecode, with the help of DEX compiler, will be converted to .dex, that will be running in the Delphic virtual machine. So this is the complete process. So that DEX file will then finally be executed on the Android phone, and then you will be able to use it. We have seen the two approaches, just in time and ahead of time. We have discussed it previously that in the just in time approach, what we used to have, that every time we had to run that app, this compilation happened. The Java bytecode used to get converted to .dex, and then it was executed on the app. Whereas on the Android, similarly, in ahead of time, what happens is, for once, when you are installing the app for the first time, when you are installing the app, for once, this compilation into .dex will be completed, and then every time you are executing that app, this .dex file, it will then get executed. This .dex file will then be running. So that is ahead of time. After Android 4.4, that is Android 5.0, we have got ahead of time. Before that, we used to have just in time. So this is just a brief overview of what we have already discussed previously in detail. That is the Java, the Android compilation process. It is very important for you to keep this thing in mind, so that all of the upcoming discussions that we have, you are able to quickly grab them, you are quickly able to understand them. So here, this is the compilation process. Now, as I mentioned that APK file, it is simply an archive. So what we do with zip files, we simply unzip them. So if in case we have got any of the zip file, like I have the activist Android notes by Rohan.zip. Like let's say you have got this zip file. So as soon as you get a zip file, what you do? You extract it. Maybe you extract it with 7-zip, DE-zip, WinRAR, any of the extractor you can use. Maybe you can use an extractor from the operating system, from Linux, from Mac, from Windows, and you can simply extract it. As I mentioned, that an APK is also a archive, so you can extract this as well. But there's a catch. The catch here is that once you compile this, once this complete compilation of the Android app happens, the final output that you will be having, it will be in the form of a binary data or maybe in the form of binary resources. Binary is the machine level language. We as humans will not be able to read or understand the binary data. It is only machine readable. So what do we do in that case? So in that case, what we do, instead of extracting the APK file, we decompile it. There is a difference between them. First is extract and the another one is decompile. Why we do not extract? We can extract, like we have got any of the APK file, so we can simply do unzip like rohan app.apk, and then we can simply extract it, we can simply unzip it because it's an archive. But the output that we will be having from this will not be human readable. It will not be human readable because it will be in the binary format. So what we do, we decompile it. What is compiling? You have got English like code, like you write import Android, then you write the functions like print hello world and then execute. So that is an English like code. You compile it into binary so that machines can understand it. Decompiling is the reverse of it. What happens in decompiling is the binary code that you have, that binary code, it will get converted to English like code. It will get converted to high level language. You must have read about high level language, low level language. High level languages are all of those languages that the humans can read, can understand, like English, or if I talk in terms of programming, Python, or maybe C, C++, Java. These are all of the languages that we humans can understand easily. Low level languages are those languages that machines can understand, like assembly languages, small e, or this binary also. These are low level languages. So what we want to do is all of those code that we have in the low level language, we want to read them in the high level language. So going from binary to high level language is decompiling, and going from high level language to low level language is compiling. I also write it down for your reference. High level to low level is decompiling. So for that reason, what we need to do is we do not have to extract, we have to decompile. Now, how do you do that? I have mentioned that for any of the APK file that is an archive, you can decompile it. So how do you do that? For that, we will have a quick demonstration. Like if I give you any of the app, like this is my virtual machine, this is my Mobaxler, and here let's say I have got Twitter. This is the Twitter app. For this Twitter app, I want to extract the APK and I want to decompile it so that I can read it. How do I do that? Now, for that, the first thing that we need to do is that we require this APK. If in your pen testing project, your client has given you the APK, in that case, you can directly decompile it. Otherwise, if the app is installed on your device, if the app is installed on your phone, in that case, you can extract the APK with the help of ADB. So how do we do that? Like here, this is the Twitter app that I just ran. Like I'll be opening it again for your reference. This is the Twitter app. I believe I can also zoom it in. Yeah. So here this is the Twitter app. For this, I want to extract the APK. How do I do that? Extracting the APK here does not mean unzipping it. Here extracting means from this mobile app that I have, Twitter, I want to get the APK of this. For that, you first of all connect your device like ADB connect, and then the IP that is mentioned in this title bar here, you give that. We have already seen a detailed discussion on ADB and how do we set this up. So 192.168.190.102, using this you get yourself connected. Here ADB has been connected. Now the first thing that we need to do is that we need to get the package name. Here I'll write how to pull APK. The first thing that we do is that we run ADB connect to get connected to the emulator slash Android device. Second thing that we need to do is that we need to get the package name. I mentioned that for us humans, its name is Twitter. Whenever we say that I am using Twitter, so here this is Twitter. For Android, all of the apps are denoted by their unique package names. You must have seen com.twitter.app, com.mini.opera, com.zomato.food, like that. So that is the package name. So for us to be able to get the package name, what we will be doing is with the help of ADB shell, we will be able to get the package. So the first thing that you do is that you run the app, make sure that your app is running. Even if in case it is running in the background, that is also fine. We just need to get this app running in the process because we will be executing ADB shell PS, that is here short for processes, and then we hit enter. All of the processes that are running in our Android device, they will be shown to you here. These are all of the processes that are running. Now if in case you see that there are a lot of processes, Rohan, and how do we extract out the Twitter? So for that you can simply run ADB shell PS and then you use pipe. Pipe symbol that you have, it will be giving the output of this command as an input to this command. So what I'll be writing, I'll be writing grep -i Twitter. What I want to do with the help of this command is that first of all list out all of the processes that are running in my device, then from the output only show me those lines that contain Twitter because I want to get the APK for Twitter. So I'll be writing this, and now when I hit enter, you can see here that I have got the name of the package com.twitter.android. When we did not run the grep command, you can see this is what we have got when we wrote ADB shell PS. All of the processes that are running, we are able to see that. But if you are interested only in any of the given app, you simply write grep -i and then you write the app name. Like I wanted to see it for Twitter, so here it is. I'll be writing this command down for you in the notes so I can share it with you later. So here we have got the name of the package, that is this one. I'll be also mentioning it. This is the name of the package com.twitter.android. This is decided by the developer. The people who develop Twitter, they have decided this name. Any of the app can have any of the package. It's up to the developer. So the first thing that you do is that you get the package name. Second thing that you do is that you get path to the APK of that package. So what we need to do is, as I mentioned, that when you install any of the app on the Android device, the APK for that particular app, it will be stored in the files. How do you get the path to that? For that, you will be using ADB shell PM. PM here is short for path manager. You need not remember all of these things, all of these syntaxes. In the upcoming discussions, we will be having a lot of practicals. So with time, with practice, you will be able to get used to it. You will automatically be recalling them on time. So no need of mugging things up, no need of going again and again, sitting, speaking it 10 times, 20 times, that is not required. We will be practicing a lot. Just make sure that you practice things manually in the initial phase. So ADB shell PM, PM here is short for package manager. What we want to do is we want to see the path of this package com.twitter.android, and in the response you can see that in this folder slash data slash app slash com.twitter.android1 slash base.apk. This is the APK file for the Twitter app that has been installed here. So using this command adb shell pm path com.twitter.android, you will be able to get the final place, the exact location where the APK for that app can be found. So for Twitter, this is where we have. So this will be the syntax. You write adb shell pm path and then the package name. So this is using this, you will be able to get the path. The next thing that you need to do is you copy this APK from the Android device to your Mobaxler, or let's call it virtual machine. In our example, it is Mobaxler. For that, when we were discussing ADB, I mentioned one of the commands, that is ADB pull. Pulling always happens from the Android device. I mentioned two terms. One is pulling and one is pushing. Pulling always happens from Android device to virtual machine. I technically should not call it virtual machine. I should be calling it terminal. But just so that you can understand that this is what it means, I am calling it virtual machine. Technically, here it should be the terminal. Terminal from which you are executing the ADB shell, ADB commands. So from the Android device to the virtual machine, that is your terminal, that is pulling. And when you are sending something from virtual machine to the Android device, that will be pushing. Here what we have to do, we have to do it from the Android device to the virtual machine. So we will be using ADB pull. So we write ADB pull and then the path to that file. This is what we want. So I'll be creating a new folder here, mkdir, and let's say I call it source code. I go into it, and now I will be running adb pull and then this file, copy, paste, enter. Done. It has mentioned that this file has been pulled this much bytes. If I do a ls, here you can see we have got base.apk. Now here a quick suggestion from my experience: whenever you extract any of the apk file for any of the apk, it will always be named base.apk. If in case I extract this traveler, or extract I pull this stitcher, all of them will be called base.apk. This is the name by which those APKs are saved in the files, in the package manager. So in the dedicated folders that are assigned, I mentioned in the previous discussions as well that as soon as you install any of the app, a folder is created within slash data dedicated to that app by the package name. Like for Twitter, the name of the package is com.twitter.android. So by that package name, a folder will be created and all of the data related to that package, related to that app, will be kept in that folder. And for all of the apps that will be saved, that will be having the APKs saved in the files, it will be named as base.apk. So I have made it a habit that whenever I will be extracting or whenever I will be pulling any of the APK from the device, I will be renaming it to its actual name. Like here I have extracted it for Twitter, so I will be renaming it to Twitter dot apk. Please keep this thing in mind that you also write the extension. Like here, if it is base.apk, you rename it to twitter.apk and not only Twitter. Also include the extension. Now, if you see, we have got twitter.apk. Our first task that was to pull the APK of this app, it has been done. How do you do it? First of all, you get the name of the package. You do that with the help of ADB shell PS. PS will be showing you all of the running processes. And for us to be able to show that app in the processes, we need to keep it running. Maybe in the foreground, maybe in the background. We just need to keep it running here. So here the app is running. It may be running in the background. Like here you can see in the recent, Twitter is running, the app is running. Then because we wanted to extract the data specifically for Twitter, so we wrote grep -i, then we wrote Twitter, the app that for which we want to extract the APK. So we got the package name. Then we write ADB shell PM path. PM here is short for package manager. Path here will be telling ADB that for this package name, show us where is that APK file saved. For this particular package name, where that APK file is saved, here it has returned us the complete path. Now for us to be able to extract, for us to be able to pull the APK file from the Android device, from the emulator, we wrote ADB pull and then this path. Then this file was downloaded to our machine. It was pulled to our virtual machine. And then as I mentioned, my habit that anytime I will be getting base.apk, I will be renaming it to its actual name. Currently we are doing it for Twitter. So I'll be doing it for twitter.apk. Now if I unzip it, like I mentioned that we can extract it because this APK file, it is an archive. So I write unzip and then I write twitter.apk. And now when I do this, it says it cannot find or open twitter.apk. Okay, it looks like I have made a typo here. I made it T double W. So I'll be making that a correction now. Twitter.apk. And now I'll be doing unzip twitter.apk, enter. Now it has extracted the files for us. If I do a ls here, you can see these are the various files that have been shown to us. If in case I do a cat android manifest.xml, you can see the data here. The files have been extracted, the folders have been extracted, but the data that you have in here, you can see this is the binary representation. We are not able to read this. Here you can see this is the binary data. Some of the data is being shown like android.dmr request, android inbox, android. So this is not human readable, all of this data that you have. And not only this one, any of the other file that you try, like you try to read cat resources dot arsc. Here also we have got the binary data. We are not able to read all of the content. Some of them are readable. You can see we have got the white spaces here, black spaces here. So we are not able to read them. We are not able to understand what is happening here. This is why, though APK is an archive, but it is a compiled archive. So we do not have to extract it. We have to decompile it so that The low level language code, this code that you have here, you can read this. See here, when you try to read like cat android manifest.xml, you can see here that this data is in the binary format. You cannot read this, you cannot get the most out of it. This is not the high level language, this is extraction. But if you decompile it, now for decompiling it we have got multiple options. These days there are a lot of online decompilers as well. Like you go to Google, you search for online APK decompile, and they will decompile it for you. That option is available, but that option is not recommended. The reason why it is not recommended is because during your pen testing engagements, you will come across a lot of APKs, you will come across a lot of apps that are for internal use only, that are private apps. Because bug hunting happens on the public apps, you can do that. But in pen testing, if any of the app is private, the APK that is being shared with you is confidential. It is not for the public. It is accessible only to a specific set of people. Those types of APKs, those types of Android apps is not for everyone. And when you upload that APK to any of the online decompiler, you cannot be sure that the APK that you are uploading, that when you are uploading it to the server, that is stored safely, that will get deleted after 24 hours or 48 hours. Even if in case the application tells you, the online decompiler tells you that after 24 hours your app will get deleted, your APK will get deleted, the decompiled apps will also get deleted, I would suggest that you do not trust them. I will not be naming any of the API decompilers. Not everyone will be doing this, but you cannot depend on the security, on your privacy, on for any of the third party vendor. So for that reason, I would suggest that you do not rely much on the online APK decompilers. This is the major reason. Is because, as I mentioned, that I would want to get all of you as very good consultants, as very good pen testers. For that reason, this is not suggested. Instead, the local options that we have, the options that have been used by the researchers from years, and they have turned out to be foolproof. They are the most reputed ones, so you use them. The most popular app that you can use for decompiling and then recompiling any of the app, that is APK tool. It comes pre-installed in Mobaxler. You simply run APK tool, then you write D. D here represents decompile. So what you do, you write APK tool space D, and then you give the APK file. So I'll be creating a new folder here, APK tool. I will be copying the code, the APK that we have just got for ourselves, that is twitter.apk, and I'll be copying it to APK tool, so that I can show you the difference, that when we have just unzipped with the help of unzip twitter.apk, when we unzipped, this is the output we got, and when we decompiled it, this is what we got. So here I'll go into APK tool. I have already copied my APK here, so I'll do APK tool. D here is short for decompile. Please keep this thing in mind, that there is no hyphen or dash here. It's a simple D, no special symbols, and then you write the name of the APK file. So APK tool space D space twitter.apk. Now decompiling is happening from low level language to high level language. Here, all of the data that we had in that APK, it has been decompiled. If I do a ls, I can see a folder Twitter here. Previously, when we did ls, we did not have any of the folder. We had only twitter.apk. Now, when I have decompiled it, I have got a new folder Twitter. I go inside this, and here these are the data. Now, if I show you the contents of Android manifest.xml, cat Android manifest.xml, now you can see all of the data that we have. It is in the high level language. We can see that, we can read it, we can understand it. This is the decompiled version. This is the decompiled form. As you can see here, we are inside the APK tool. Now, if I again show you the contents of what we had previously, I went two folders up, and now when I show you this, you can see this is the extracted one. This is unzipped one. But if I show you the decompiled one, this is the decompiled. This is why, as a pen tester, as a researcher, we need to get the APK from the app. In most of the cases, you will directly be getting the APK. They will be sharing the APK that Rohan, this is the APK file and this is the hash, the SHA-256 or SHA-512, so that we can ensure that the application that we are testing is the same application that has been given to us by the client. In the report also, when you will be writing the report in the executive summary, in the scope, you will mention that these are the following assets that we have tested and these are the hash values. Like this is the Android, APK. This was the version is optional, and this is the hash, so that they can verify that this is the application that we have given them, that they have tested for. This is the decompiled version, as you can see. So the first thing that you can do after getting the APK is that you can decompile it so that you can read it. Now, if I do a ls here, there are other things as well. Like you have got the assets folder. If you go inside the assets folder, you can see a lot of files here. You have got legal.html, you have got experiments.json, you have got fonts, you have got properties. So in some cases, in the assets folder, you can also get XML files. In some cases, you can also get PNG files. Those things that are related to the application, that will be used by the application, you can see them in the assets folder. Similarly, we have got lib. If I show you the contents of lib, you see ARM EABI, ARM EABI V7A, and x86. Lib folder here is short for native libraries. All of those native libraries, you remember when we were discussing about Android architecture, I mentioned that in here, right beside the Android runtime, I'll show you the Android OS architecture one more time. Here you can see these libraries: Surface Manager, SGL, WebKit, SQLite. All of these libraries, they are compiled according to the architecture, according to the processor. So these are all of the various different architectures that we have: x86, SARM, EABI, ARM, EABI, V7A. These are the various architectures, so that this application can run on different architectures, on different processors. These native libraries are pre-compiled and they are put in this lib folder, so that when this app is run on the different architectures, with the help of these files here, depending upon the architecture, depending upon the processor, it can run. So in the lib folder, you will get to see these various architectures. It is not necessary that in every APK you will get the same value, same folder. different APKs, different apps, they can have different contents of the lib folder. So it is subject to the application developer, it is subject to the client on how do they want to operate. So this is the lib folder. I am currently giving you an overview of this is what you will get to see in an APK. Then we have got original, see the contents of the original. This is Android manifest, and here we have meta inf. In meta inf here is short for meta information. So more details related to this like ls original slash meta inf. Here, this is the certificate cert.rsa, cert.sf, license, manifest.sf, notice, services. This certificate here refers to whenever you will be developing any of the Android app, you need to sign it. Signing an Android app means that we at this organization, we have developed it. Consider it this way, that when you are issuing any of the circular or when you are issuing any of the notice, right below you will be writing your name, you will be doing your signature, and you will be putting a seal, so that the people who are associated with that circular, who are reading that notice, can understand which authority has signed this or which authority has issued this. Similarly, in Android apps as well, right before you release them, those Android apps are signed with the help of public keys that this particular app has been developed by us. So when Twitter uh, created this app Twitter and they were to release it, at that time they signed it with their own keys. Signing any of the API key is a vital process. Without that, you will not be able to install those applications into your phone, into your Android device. How do you sign it? How do you create your own signatures? We will be discussing them in the upcoming discussions for sure, because as I mentioned in the upcoming discussions, not necessarily in the next discussion, in one of the upcoming discussions, we will also be reversing an application, adding our own Trojan to it, signing it, and then sending it to the victim. And then we will also see that Trojan in action. So in that case, we will be able to see the signing process. So we will be learning signing as well. With the help of jar signer, we can do that. So this is the first method. Yeah, I was mentioning about these files that you have in the APK. We have discussed about assets, lib, original. Another one that you have is this resources. Res here is short for resources. Mostly the image files that you will be having. Like when you open any of the Android app, you get to see the logo of the organization on the top left corner here. When you open Twitter, so here these photos that you get to see, the logos that you get to see, when you click on login, this logo here, these various things that you get to see here, all of these resources, we usually call them static resources or static assets. They will be found in the res folder, that is the resources folder. These are the various folders that you have in here. These are the subfolders of res. So when you will be developing any of the Android app, in the res folder you will be able to get these resources. You can also get the png, svg, xml, html, any of the other resources that you want to have, you can have them here. After that, you have got the smalley folder. Smalley is another assembly language. Like if you see the contents of smalley, you will be able to see the smalley code here. So as I mentioned, when any of the compiler will be compiling the code from high level to the low level, how actually a compiler works. Compiler will always be converting first the high level code to the assembly language, then from assembly language to the low level code. So Smalley is a type of assembly language, and the code that we have, it is present here. So if I show you any of the code here, slash Smalley slash, let's say, jn.smalley, this is the Smalley code here. This is a type of assembly language. This is similar to assembly language. Here, dot class public ljn dot super ljava lang object dot source twttr. These are the static fields, instance fields. This is how a smally file looks like. So when you will be going ahead with security researching, in that case a smally file will be very helpful for you. And then the last one that we have is unknown. So for all of the miscellaneous data that you have, miscellaneous files that you will be having, you can find them in unknown, like here. So we have got phone number, metadata, proto underscore gi here. So let's see if in case we can get any of these files, we can see them. Let's see. So cat unknown, and let's get phone number, metadata, proto, and gi. This is the data that we have in this folder. All of the applications, all of the APKs that you will be decompiling, they can have different files in here, but the overall structure will be remaining same. You will always have Android manifest file, you will always be having assets, always be having lib, res, smally, you will always be having them. This is for sure. Android manifest file will be the most important file. Once you decompile any of the Android app, the first file that you visit for the review is Android manifest. It is so crucial that without having a read of Android manifest, you will not be moving forward with the further testing, with the further researching. We will be dedicating a discussion related only to Android manifest. There is so much to discuss on this, so many things. The all of the IPCs that you have, that is inter-process communication, activities, broadcast receivers, content providers, services, intent filters, implicit, explicit, all of them we will be discussing when we will be learning about Android manifest. So this is the first thing that you do after you want to decompile any of the APK. So this will be the basic structure of any of the APK file that you have. We have at the moment discussed one of the ways by which you can simply decompile any of the app, that is APK tool. Similarly, there are other methods as well by which you can do that. Another most important of them is dex to jar. As I mentioned that in any of the Android application that you will be having, you can convert the delete bytecode to the Java, to the Java code. For that, in your mobile Explorer, you will be having D2J slash that is hyphen dex to jar. What we will be doing, we will be simply writing D2J hyphen dex to jar, and then we will be giving the name of the APK. So I write here, do we have? No. Here, so here we have got twitter.apk. I'll create a new folder D2J, that is dex to jar. I have a habit of creating the folders so that it becomes easy for me to be able to segregate and categorize the content. So I write mkdir d2j hyphen dex to jar, and all of the operations that I will be performing on this Twitter app, I will be doing that in this folder. So I have copied this APK file to this folder, and now I will be going inside this folder. Here, these are the contents that we have at the moment. So what we do, we simply write d2j dex to jar and then the APK file, twitter.apk, enter. Now, this particular APK file that we have, that APK file will get converted to its equivalent Java code. Dex to jar will be converting this APK to its equivalent Java code. It will be taking some time. It is decompiling at the moment. Now decompiling is done, and now when I do a ls, you can see that we have got a file twitter _jar. Previously when I did ls, I had only twitter.apk. Now I have this jar file as well. For us to be able to see this jar file, you have to use _gui. _J is yet another quite popular Java decompiler. So you can simply run _J, the name of the file, and then it will get decompiled into Java. _GUI is its equivalent version for the GUI. So you simply give _GUI, this is the command, and then you give the name of the jar file. So _GUI, then twitter dex2jar.jar, _GUI, dex2jar, APK tool, all of them will be pre-installed in your Mobaxler. Now that jar file is being loaded, and here you can see this is the source code, these are the resources. Why do we use _GUI? Because we will be able to see all of the code in the form of a graphical user interface. So here I go to com, twitter, android, and then I go to any of the code. Like here I go to issue activity, and here you can see the Java code. If you have ever done Java coding, you will be able to understand that yes, this is how the Java code looks like. This is the name of the package. These are the libraries being imported. These are the classes, and these are the various data that we have in those classes. Here you can see string 3 equals to get string, and then this is the data string 2 equals to get string, this is the data string equals to private information, like this. Here you can see the data has been obfuscated. This is quite an important statement to keep in mind. We will be discussing about this obfuscation in detail. I will even show you with the help of Android Studio. I will be having a sample code that, see, this is the code, this is a sample Android app, this is how you run this app, this is the source code. When you will be releasing this, when you will be releasing this as an APK, so you can also obfuscate. You can do that with the help of ProGuard. This is one of the options that you have in Android Studio. With the help of ProGuard, you can obfuscate the code. Quite an interesting thing to do. We will be discussing about this in detail, because here the app that we have that we are analyzing at the moment, it has the obfuscated code. So for that I'm mentioning it here. In the upcoming discussions, when we will be discussing about obfuscation, I will show you a practical demonstration that if you obfuscate the code, this is how it looks like, and if you don't do that, this is how the code looks like. So this is how you can see the code. The Twitter app that is running here, this one, this is the code for it. Now because the code have been obfuscated, you see AZ, AY. If you want to search anything here, you simply go to navigation, text search, and I write log.d, let's say, and then I search it. In the complete code, wherever you will be having log.d, you will be able to see that here. No focus mode, camera open exception, camera is not created yet, preview of camera is not created. All of these will be shown in the logs. There are significant issues related to logs as well. When we will be discussing them, I will tell you about the various commands, various functions here, like log.d, that is log daemon, log.e, log.v, log.w, log.i, all of the various functions that we have. At what point, for what reason will the developers will be using which function, we will be discussing that as well. So this is how you can decompile and see the code for any of the Android app. Now all of the testings that we will be doing, we will also be analyzing the code here, we will be analyzing the security issues here, We will be analyzing the logs also. Depending upon what is the security issue, we will be moving forward. And for all of the security issues that we have, we will also be having the source code analysis. That see here, this security issue is happening here because in the source code on this line, this is not configured properly, because in the source code on this line this has been written. For that reason we have this problem, and for us to be able to fix that bug, these are the changes that we should be making. This is how you operate. So the agenda for the day was to understand about APKs, why APKs are archived, how to pull the APK of any of the app that is installed in your device, how do you decompile it, and how do you see the code. We saw that a APK file is an archive. You can have various files in it. You can have the Java or the Kotlin code, PNG files, SVG files, XML files, certificate files. This is the Android compilation process. You write the code in Java. With the help of Java compiler, you convert it to Java bytecode. Then with the help of DEX compiler, you convert it to Delvic bytecode, that is .dex. Then that .dex file, when you will be executing that app, when you will be running that app, that dex file will be running in your Android sandbox, in your Android device, depending upon your architecture. We saw revision of just in time, ahead of time. You can do both of the things. You can extract the APK with the help of unzip. You can decompile them. Then we saw what is decompiling, from low level language to high level language, from binary to Java, that is decompiling. Why should we not unzip? Like, even if in case you unzip, you will not get anything out of it. We also saw a practical demonstration of what happens when you unzip. Then we saw that for any of the app that is installed in your emulator in your Android device, how do you get its APK? First of all, you get your terminal connected to the device, to the emulator. Then you get the package name with the help of this command. Then you get the location of where that APK is stored in the Android device. For that package name, you take help of ADB shell package manager here. Then we saw the differences between pulling and pushing. We pulled the APK file, then we decompiled it with the help of APK tool first. Then we decompiled it with the help of dex to jar. We had the APK, we converted that to jar, and with the help of JADX GUI, we saw the GUI, we saw the Java source code of that file. This is how you pull the APK, you decompile the APK. This is the first step on any of the project that you are working, may it be pen testing, may it be bug hunting. This will be the first process, having the APK and decompiling it. We also saw an overview of what are the various things that you have in an APK. What is the lib folder, what is the assets folder, what is the resources folder, what is the unknown folder, what are smally folders, what do they contain. A brief overview of all of them have been seen. I intentionally did not discuss about each of the folders in detail. Reason is, if in case I discussed in detail about each of them now, there is a possibility that you might get confused, or you might feel that you are bombarded with a lot of information, and gradually you might lose interest. So I want to keep things interesting with you. At the moment, the things that were necessary for you to learn have been discussed. In future, when you will be requiring a detailed information about any of the folder, about any of the file, I will be again discussing them in detail. In the upcoming discussion, we will be discussing about this Android manifest file. I mentioned that Android manifest file will be playing an important role. So for that reason, we will be discussing that this Android manifest file that we have, how do we analyze it? How do we read it? And then how do we get the most out of it? If in case there are any of the reviews that we need to do in perspective of the security, how do we do that? Tomorrow we will also be learning about IPCs, that is inter-process communication, activities, intents, intent filters, broadcast receivers, content providers, services. We will be discussing about them and consider this to be the core. Without IPCs, you will not be able to perform manual Android pen testing efficiently. Without knowing what activities are, without knowing what splash screens are, without knowing what content providers are, without knowing what services are, you will not be able to work on the projects efficiently. Please make sure that you mark your attendance in the tomorrow's discussion. It is going to be crucial. Now, if you have any questions or queries, we can discuss them.
Yes, Rohan. I'm experiencing an error while decompiling the application using APK tool.
Hmm.
I've shared the image also in the WhatsApp group for you to view, please.
Sure, you can send it in the group or you can also DM me.
Yeah, yeah. I have already sent it in the group.
Okay, let me see.
Yeah.
Maybe you are using the different version of APK tool. It also happens sometimes that there are specific versions of any of the CLI tool. I'm not talking specifically about APK tool. In some cases, I have noticed in my experience, my colleagues have also noticed this, that sometimes when you are using uh, certain version of any of the tool, they tend to give you errors. So what I would suggest at the moment is that try decompiling any other app at the moment, and if in case you get the same error, try downgrading APK tool and see.
Okay. Yeah, because APK tool is didn't already installed in my system, so I tried install using like sudo. So maybe the case is this. So another question is like dex to jar and APK tool carries the same functionalities like decompiling.
Dex to jar will be converting your code into its equivalent Java source code,
Ah, okay,
whereas APK tool will simply be decompiling it or will be extracting it into its equivalent folders. It will not give you the Java source code. That is a significant
right.
difference. You must have noticed. I will show it to you. I'll start sharing my screen again. I'll show it to you. Like here, we are into this APK tool. So when I ran APK tool d twitter.apk, I got this folder. And
Mhm.
in this folder, we have got the various files and folders related to
Yeah.
twitter.apk. But
Mhm.
when I ran dex to jar on this APK, I got to see this jar file. And this jar file,
Yeah.
then with the help of 𝗧𝗃𝗶𝗹𝗯𝗍, I will be able to see the source code. So this is the significant difference between the both.
Okay. Thank you so much.
Now, if anyone of you has any questions or queries, you can stay back in the room and we can discuss. I'll be the last one to leave the room. Most of you have marked their attendance. If you have not marked their attendance, please make sure that you write your full name in the chat box. I'll share the attendance with the management team. If you do not have any questions, you may leave the discussion for now. Please make sure that you attend tomorrow's discussion. It's going to be vital for all of our upcoming discussions. Till then, have a very good day, and I will see you tomorrow for sure. Take care.
Yeah. For APK tool, I'll try it with the different app if it works, or otherwise I'll downgrade the version of one.
Sure, sure, sure. We can continue the conversation over the private chat.
Yeah, sure. Could you please share the today's notes for just viewing reference?
Sure, I'll do that right away.